I'm going to get rid of this, and we're going to plot some points for the g of x function. Because it reflects over the y-axis, I know it's got to be over here, and it will not be with any positive x's. So I'm going to pick a bunch of negative x's. Maybe I'll pick like a, I don't know, a negative 0.5 maybe. All right, maybe 0. All right, sorry, not 0. I meant negative 1. Negative 0.5, negative 1, negative 2, negative 3. Let's plug these in and see if we can get the shape. Honestly, I don't really care which numbers you guys plug in. You should be able to get the shape of it so that on your homework, because it's like multiple choice, right? You should be able to really identify which of their graphs matches the numbers that you were getting. All right, so at the negative 0.5, again, I'm putting it into this g of x, the purple one here. It was, here's my log button, log of negative 1/2 times x, and I'm going to treat a negative 0.5 as my x. All right, so messy number, that's fine. I'm going to round to the nearest tenth. I'm going to go negative 0.6. All right, at negative 1, let's do the same thing here. You guys bust out whatever calculator you're going to use on the homework. I'm subbing in a negative 1 now. Check out the parentheses. Notice that it does log of, and then it's got parentheses around the whole thing. All right, I got a negative 0.3 this time. Did you guys notice that it grew like very little at all? And these are actually counting, it's counting by 2s. Maybe I'll step this up a notch. Maybe I'll count by a bit more. Maybe I'll go up to like a negative 5 or something like that. Or to like a negative 10. Let's check this out. Really, like I said, though, you can plug in whatever numbers you want. I'm just trying to see if I can get the shape of this graph. So I plugged in the negative 5. Messy, that's fine, but it's a positive number now. It's actually at a positive 0.4 if I round to the nearest whole number. All right, and then negative 10. Let's see. Same deal. Negative 10. Does anybody have any questions on their calculators, how to do this? Like Tabitha, Jack, Sadie, Laura, Crystal, are you guys getting the same answers that I am? You got it, Jack? All right, Laura, you got the same thing? All right, so we're finding this out on our calculator. Awesome, thanks guys. All right, so when I plugged in the negative 10, I'm gonna run this to a 0.7. Again, this is just helps me like ballpark what it's gonna look like on the multiple choice graphs. So at a negative 0.5, I got a negative 0.6. So here's my little past negative 0.5 is my negative 0.6. All right, at negative 1, again, this is counted by 2, so negative 1's like in the middle of these guys. Negative 1, I hit a negative 0.3. So let's see here. Negative 0.3, like in the middle of that guy. All right. At negative 5, here's my negative 5. That hit at a positive 0.4, so it's a little short of the 0.5. And at negative 10 right here, I hit a 0.7. So a little past my 0.5 here. This is my 0.7. All right, so here are some points that I can connect. So this looks like it hits 0 at negative 2. Let's check that out. Does that actually hit 0 at negative 2? Put negative 2 in here. I didn't test that one. I just want to check and see if it's on track. And yes, when I put a negative 2 in, I should get a 0. All right, so it's got the point negative 2, 0. Looking good. So let's see if it actually gives the transformations that I was going for. Reflection over the y-axis. Okay, so it did that. It reflected over my y-axis. Horizontal stretch. So it's like they took the end of this and stretched it horizontally. So it kind of got pulled and like a little shorter. It kind of got pulled out here. So yeah, I think this one looks like it hits both of those transformations. All right. So this one was kind of nice because you see the parent function, what I have in black here, the parent function was your log x, which you have a log x button on your calculator. Let's try out something like number 2. This is a log base 1/2 of x. All right, so here's my f of x here, my original function. And I don't have a log base 1/2 button on the calculator. So I don't know about you guys, look at your calculator. Mine says log, like a log base 10, or ln, natural log, like a log base e. Those are the 2 log buttons that I have on here. So look at yours and see what kind of log buttons you have. So like Tabitha, what kind of log buttons do you have? Same as mine, okay. So Sadie, do you have the same ones? Yeah, okay, I think most calculators do. So Sadie, pick one of those. Do you want to do the common log or the natural log? Honestly, I don't care which one you pick. Common log, okay. So if we're going with the common log, what I'm going to do over here is, we talked about this before, this is the change of base formula. I'm going to change this from a base of 1/2 to, Sadie chose the common log, so we're going to change it to that base 10, our common log. So here's what I got to do. Log base 1/2 of x equals my common log of x over my common log of 1/2. So this I can actually enter in my calculator because I have that log button on my calculator. If you changed it into natural log, like say that you just chose common log, if anybody chose natural log, you honestly should get the same exact answers. So like I'm gonna plug some x's in here off of my parent function. I'm gonna put, let's see, it should be like this parent function where it's all a bunch of positive x's. So I'll go with like I'll go positive 0.5, 1, 2, 3, 4. Actually, let's go with those guys. Okay, we're gonna put these in for the x. I'm gonna show you guys how to do one of them, and then you guys gotta try and find the rest of them. So I'm gonna plug in my 0.5. So I'm gonna do log of 0.5 divided by log of 1/2. Bam, 1. Okay, so that got me a nice pretty whole number. All right, so you guys take a sec, do this exact same thing. The only thing you're changing is your 0.5. You're gonna change the 0.5 into like a 1, and then a 2, and then a 4. You're gonna change that 0.5. The rest of it's all the same. All right, so Erin, are you there? Erin's there, awesome. So Erin, plug in the 1 here. Do log 1 over log of 1/2. Let me know what you got. And then Josh, will you plug in the 2? Plug in the positive 2. So do like I have in my calculator, log of 2 instead of the 0.5 over log of 1/2. So yeah, Josh, you plug in the 2. And then let's see here. Chase, will you plug in the 4? Yeah, the 4. So, and do it like you would with this change of base formula in your calculator. Awesome. So Erin, you subbed in the 1, you got a 0, so we have to put in 1, 0. I do know that I should have an asymptote here on my y-axis, so it looks like all the numbers I'm getting should be positives. If you guys get a negative, you know something's a little off. So guys, let me know, just let me know what you got. I'm gonna start plotting these points. At 1/2, I got a 1. Yeah, you're plugging it in for this x right here. So Chase, you're plugging in a 4. You're gonna do log of 4 over log 1/2. All right, so at 1/2, I got the y value 1. So there's my point 1/2, 1. 1, 0, there's that guy, there's that point. Keep it coming, guys. Jess, are you okay with that too? All right, you got it, Laura? All right. All right, so what'd you get, Josh? -1. -1 here. All right. It's looking pretty good. It almost looks like a straight line though. Chase, you got an error. Let's check this out. Were you using this log button? All right, so log of 4, and then are you going to end the parentheses right there? Check out those parentheses. Log of 4, end the parentheses, and then divided by log of 1/2. All right, so this is what I got. Oh, you did get it? Okay, cool. So at -2, so you got the 0.4, -2. All right, so it kind of looked like a straight line for a bit there, but now I can tell it's curving, and it should not cross the asymptote. So it gets really close, curves away from it. Okay, there we go. Okay, any questions on my parent function? I'm doing all right. All right, we're going to do this g of x function right here. So you know how we had to do the change of base formula on my parent function? I'm going to have to do the change of base formula on this function as well. So let's see that. If I do the same formula, it will be 2 times, if I go with the common log again, it'll be common log of the x plus 4 over the common log of this base 1/2. So this was a change of base formula. We changed those both into a log base 10, and I still have the 2 out front here. All right, so that's how I'm going to enter it in my calculator, but let's see what kind of graph am I expecting to get. Let's look at the transformations. So log base 1/2 of x, log base 1/2 of x. It's got some stuff on the outside here though. Let's see, the stuff on the outside, that 2, it's multiplying by 2. So if you can look at this if you like. Multiplying by 2 on the outside. Anytime I multiply by something on the outside, it's going to be a vertical stretch or shrink. And we're multiplying by 2, which usually when you multiply by 2, it like doubles stuff. It's going to make it bigger. So this one was a vertical stretch by 2. All right, and I still have to deal with this plus 4. That is in the parentheses with the x, so that will be kind of like this guy. And it was plus, right? Yeah, it's plus 4. So it's kind of in this category where I am shifting to the left. In our case, we're going to the left by 4. Oh, come on. Now, let's clarify for a second here. If I do a vertical stretch on the asymptote, I mean, this asymptote has arrows on the end. Like if I stretch that like vertically, it's going to keep going to infinity. It already goes to infinity. That's not really going to change off of the stretch. But shifting to the left by 4, 1, 2, 3, 4, that does change where the asymptote is. The asymptote is now over here at -4. Okay, so I found the transformations. I kind of know the basic shape. I know it got shifted to the left by 4 and then a vertical stretch. It's like vertically they grab the end and like stretch it out. So it'll probably be like a bit longer. I don't know, in my mind it's gonna look something like that. Shifted to the left by 4, vertical stretch, but let's get some specific points. I can tell ballpark where it's at. Let's get some specific points though. All right, so let's plug some stuff here. It can be to the right of that asymptote. So I can do like a negative 3.5. I just can't do negative 4 point anything. I can't do anything to the left of that asymptote. Nice, Laura. So I found the asymptote by this whole horizontal shift here. Because I shifted everything to the left by 4, that includes the asymptote that I shifted to the left by 4. Everything got shifted. The other one, vertical stretch, I mean, that applies to the asymptote also, just it already goes to infinity, so that doesn't really change anything. Awesome. Okay, so I'm gonna, you know how this one was all to the right of it? To the right of the asymptote, same deal here. It's gonna be to the right of the asymptote. I've got really close. I got a negative 3.5. Maybe we'll go with like a negative 3, negative 2, negative 1. Let's check this out. All right, maybe a 0. All right, so bust out your calculators. I showed you in purple here. This is how I have to enter it in my calculator. I got to use that change of base formula. So move this over here. I've got to do 2, and then here's my log of x plus 4. I'm going to do a negative 3.5 in for my x, so negative 3.5 plus 4. And then that should be divided by my log of 1/2. Nice, pretty whole number. All right, that doesn't happen all the time. That turned out to be a positive 2. Okay, so I plugged in my negative 3.5. I got a positive 2. And we're going to have to do this all again. But we're going to change the x value. So you guys find those log buttons. Make sure you mess with the parentheses. Make sure you've entered the division the way it is. I'm just going to put a negative 3 in now. Oh, 0. Nice. All right, so let's see. Thomas W., are you there? Do I have both my Thomases there, actually? Nice. So Thomas Wiseman, let's have you plug in the negative 2. Thomas H., are you there? Nice. So Thomas H., will you plug in the negative 1? All right. And Jack, are you there? Jack Wiseman? Nice. Jack, you plug in the 0. All right. So you boys let me know what you got. I'm going to start plotting these 2 points that I have already, but you guys let me know what you got. All right, so far I've got a negative 3.5 and then a positive 2. So here's that point. Negative 3, 0. Okay, here's that point. And then, yeah, you're plugging in a negative 1. Nice. So you can, I show him my calculator here. This is how I entered it. So I enter it with my negative 3.5, with my negative 3. So Jack, you subbed in a 0 and you ended up with negative 4. All right, all right. What else we got? All right, so you plugged in a negative 2, right? And you ended up with a negative 2. Okay, so I'm gonna start plotting these points. I'm just waiting for that last one there. Plug in the negative 1. All right, so Let's see here, Thomas H, have you subbed in the -1? Or sorry, the -1. Have you subbed that in yet? Oh, does it say error? Yeah, okay. So on this one particularly, let's check out those parentheses. So I've got the 2 in front, and then I've got log of -1 for you. You're plugging in a -1 plus 4, and the -1 plus 4 is all in parentheses, and then divided by log, and then parentheses again on this log of 1/2, and then you end the parentheses. So check that out. Now this is what I got. I got a messy number, but it wasn't undefined or anything. So Thomas, check out your calculator. Let's see what we can adjust. Let me know if it works. Oh, you got it now? Okay, cool. So this was a -3.2 if I round to 1 decimal. All right, -3.2, there we go. All right, so here's my little curve here. Oops. There we go, -2, -2. Okay, so again, in my head, it was gonna be like shifted to the left by 4, which I do think I got shifted to the left by 4. I can see that. And I thought it was going to be like kind of vertically stretched out like this, which, yeah, I think we kind of hit both of those. All right, any questions? All right, everyone in the class is good. All right. Anybody at home have any questions? Thanks, Crystal. Yeah, yeah. Is that good, Sadie? All right, all right. Okay. All right, so I'm going to look at the stuff we looked at on Thursday, actually. This was, remember how I said if you got multiple things going on with your x's, you probably want to factor out the a, because my horizontal stretch is just what I'm adding or subtracting to the plane x. My horizontal stretch is not what's being added or subtracted to an a times x, but just the plane x. So if there's something in front of your x, I would factor it out. Even if there's a negative in front of your x, I would factor it out so you can just see what is added or subtracted to a plane x. So here's what I'm going to look at here. Here's my f of x function. It's my parent function actually with a negative x. So I think they still have this asymptote at 0, you know, on my y-axis here. But I think they did a horizontal reflection. I think it's going to look like this. Let's get some specific points, but I think that's kind of the ballpark what it's going to look like. So I'll plug in like a -0.5, like a -1, -2, probably a -4. Let's plug in these negative numbers. All right, this one is log base 2 of x. I want you guys to take a second, do the change of base formula on this so you know how to enter it in your calculator. All right, Wilson, will you outline it for me? How would I put this in my calculator? Is Wilson there? I'm not hearing back from Wilson. So let's, I'm gonna come over to Mayu. Mayu, are you there? Maybe she's not on anymore. Let's see. Who else here? Lonnie, are you there? All right, thanks, Alani. Okay, so Alani, walk me through how you're going to do the change of base on this one. Like, how would you enter this in your calculator? All right, so you have the log of negative, of whatever your x value is, you're putting the 0.5 in. Okay, we're good, thanks. Over log of the 2, because it was a log base 2. Nice. Okay, so I do think, Alani, the only thing I would adjust is because my x in this case is a negative 0.5, I got to put it in here with like a negative 0.5. It's kind of confusing, but let's check this out. I'm going to enter it like you did with your log buttons. You're going to do log of negative 0.5, actually a negative 0.5. Does that make any sense? All right, cool. And then just like you did with the denominator had to be log of 2. Good, they're both common logs. Okay, so we did the change of base. But here's where I usually see mistakes here. I had to have a negative x value, and my x value was a negative 0.5. So I kind of had to have a negative 0.5. All right, so that ended up with a negative 1. Oh, you're good, Sadie. All right, let me know if you get stuck. So I'm going to pretty much do this again for each of my x values. The only thing I'm changing is the negative 0.5 in this case is going to turn into a negative 1. But I still had to have a log of negative x, like a log of a negative 1. All right, so that gave me a 0. Next up, I'm going to put in a negative 2. Positive 1. All right, we're getting nice, pretty whole numbers. Honestly, I strategically did it that way. If you got messy decimals, that's fine. All right, I'm going to put a negative 4 in. It's like a negative 4. All right, and then I got a 2. Okay, so I'm going to plot these points. At the negative 0.5, like negative 1/2, I got a negative 1. At negative 1, 0, negative 2, 1, negative 4, 2. Okay, so here is their f of x function. Okay, it doesn't cross the asymptote. It's really close, but doesn't cross the asymptote. All right, so then we're going to look at the g of x and its transformations. So I'm going to do kind of what we were talking about up here, how you factor this number out so you just see a plain x and what's added or subtracted to your plain x. So, excuse me, if I take out the negative 2, I treat it like that, and then I think that'll make it a bunch easier, a lot easier, because I look at, I'm only adding a 1 to a plain x. I saw a minus 2 up here, but it was subtracting 2 from a negative 2x. I only want to know what's going on with the plain x. So that plus 1 goes on my plain x. That would shift everything to the left. We're going to go to the left by 1. All right, and then I also have to deal with this -2 right here. That is multiplied by all this. Actually, I'm going to have three different things here. I've got the negative. Let's do the negative separately from the 2. The negative is a reflection, and it's multiplied by, it's not a -2 out front of my logarithm. It's just multiplied inside by like the x. So the negative itself has to go horizontally like x's do. It'll be a horizontal reflection. Or in other words, it will reflect. So horizontally, left and right, that reflects over the y-axis. All right, and then the 2 is multiplied by my x. So it again is going horizontal. The 2 on that x is usually multiplying by 2 makes things bigger. Usually I'd say it stretches, but my x's do pretty much the exact opposite. This is going to be a horizontal shrink by, like I said, the exact opposite. So instead of doubling, I'm actually going to take a half of it. Okay, so there are my transformations, which makes me think, okay, makes me think it's going to be like over here on the left here, it'll shift to the left by 1, including the asymptote. So this right here, let's see, I think we did that up here as well. Yeah, so you see what I pointed over here? This shifting to the left by 4, it had to do with the asymptote. This shifting to the left by 1 also has to do with the asymptote. So my asymptote over here. All right, so horizontal shrink by 1/2. Horizontally, I think it's going to shrink in. I think it's going to look more like this, like a little steeper. There's my horizontal shrink, and then reflection over the y-axis. I think that's already taken care of. We're already on the left side of this axis. Okay, so let's see. I drew the asymptote. Let's plug in some numbers here. All right, and again, I think it's going to be over here because of the negative. It's going to be reflected on the left side of that asymptote. So maybe I'll put in like a -1.5, like a -2, -3, -4, that kind of thing. There we go. Okay. Oops, come on, behave. Okay, so it's supposed to be a log base 2, which means if I'm going to put this in my calculator, I've got to use either the common log or the natural log. I think so far we've been doing like common log every time. I'll show you, it gives you the same thing if you do natural log. So I'll put that over here. If I do natural log of the argument, which was a -2x minus 2, over natural log of the base, which was a 2. So that is this guy turned into natural logs. All right, so let's see, I've got my little ln natural log button of -2x. Okay, and I'm putting a -1.5 in for my x.
Miss Dang.
Yeah, what's up?
Is the reason we're using natural log because the rules told us to?
No, I'm showing you that it would do the same thing. I'm going to do it with a natural log, and then I'll do with a common log, and I'll show you get the same exact answer.
Oh, okay.
So I chose to do a natural log this time. Great. If I choose to do a common log of all this, -2 times -1.5 minus 2 over my, again, common log of the base, which was 2. So if I did it that way, I still got a 0. So I don't care when you do the change of base formula, it doesn't matter if you change it into your natural log or your common log, you should get the same answer. All right, so I got a 0 there. All right, so I'm going to stick with the natural log for now just because we did a common log a lot before. So I already plugged in a -1.5. I'm going to now plug in a -2. Okay. That ends up with a 1. All right, all right. Now I'll do a -3. Wow, I'm getting nice pretty whole numbers. I'm gonna plug in my -4. All right, so this is not such a nice pretty whole number. If I go to the nearest 10th, that would be a 2.6. All right, so I'm gonna plot these points here. -1.5, I got 0. At 2, I got 1, so that's actually the same point that they got. -3 hit at 2. -4 was at a 2.6, so a little over 2.5 here. I didn't really get any negatives here. It doesn't mean they don't hit negatives. I just didn't get that close to the asymptote. Like I would have to plug in, I did a -1.5. I'd have to plug in like a -1.25 or something like that. So the whole point of why I'm showing you it, this way is because on your homework, you're going to have to kind of narrow it down and figure out which of their graphs is correct. So if you can tell based off of these positive points, great. If you can't tell and you want some down here, some negatives down here, then like I said, plug in another number. Plug in like something really close to -1, maybe plug in like a -1.1 or something like that. And you can kind of see if their graph is hitting what we were going for. Okay, any questions? In the classroom, at home, let me see, you guys got questions? Classroom's good, okay. Alani's good. Okay, we did 3 different graphs. Thanks, Thomas, Tabitha. Thanks, guys. Thanks, Evan. All right, looks like we're doing all right. Thanks, Jack. Okay, so I'm gonna move on to 4 and 5. These ones, they don't have a graph. You have to write a rule for G. So here's, says let the graph of G be a translation 2 units up, which translation, by the way, also just in other words means shift the entire graph 2 units up, which up and down has to do with y's. So I'm going to take this parent function and I'm going to put like a +2 on the outside of that parent function. Okay, so that shifted it up 2. And then it also says a vertical stretch by a factor of 2. Again, vertical has to do with y values. It's got to be on the outside here. And you're going to stretch by a factor of 2, so I have to multiply it by 2. All right, so here is the g function. So I'm going to go g of x equals all this stuff. Okay, so that was with a logarithm function. I should be able to do the same thing on this guy on an exponential function. I should be able to do whatever transformations they want. So I think on this one, I do see they have a horizontal stretch by a factor of 3. Horizontal has to do with x's. Okay, this word horizontal, that has to do with x's. And stretch, usually stretch means it gets bigger. You would like multiply by 3. But my horizontal stuff does the exact opposite. I'm going to have to multiply by 1/3. Okay, and then they also had a translation, which in other words is a shift, like shift 2 units up. Up and down has to do with y's, so that will be on the outside here, the +2. All right, so here's my g function. There's my g of x with the transformations that they gave me. Okay, so you guys are gonna have on your homework, you'll have like graphing ones like these guys, and you'll have some function ones like these, even exponentials that we did last time. They could be logarithms or exponentials, any of them. Okay, any questions?